Welcome to Ask and Learn.
We want to use some kind of CAS software to graph f of x is equal to x minus tangent inverse of x squared and find the first and second derivatives using the software. Then we want to graph the derivatives to estimate the intervals of increase, decrease, concavity, find any extreme values, and points of inflection. So I went ahead and already found the first derivative and graphed it alongside our original function here on this first page. And to get our viewing window for our original function, all I did was zoom out far enough to see if we had any kind of interesting activity going anywhere. And outside of really x is equal to -2 to 2, there really didn't seem to be much. So this is the graph for f of x that I'm going to leave us with. Then when I went ahead and graphed the first derivative here, I did pretty much the same thing, and outside x is equal to -2 to 2, again, we really didn't have much information. But remember, for the derivative, the only thing we really care about, since we're looking for extreme values and where the function is increasing and decreasing, are our x-intercepts. So I just made sure I included all of our x-intercepts into this here. All right, and so the two x-intercepts I found were at 0.544 and at 1. Now let's go ahead and find where this is increasing or decreasing. So remember, to find where the function is increasing, that is where f prime of x is strictly larger than 0. So coming from -infinity, the function is larger than 0, and it will be larger than 0 until we hit our first intercept, which is at 0.544. And then from 1 to infinity, it'll also be positive. And then our function is decreasing, where f prime of x is strictly less than 0. And this only occurs between 0.544 and 1. Right. Now what we can do is determine if these two x-intercepts that we have for our first derivative are going to be maximums or minimums for our original function. So to the left of 0.544, since f prime of x is positive, that means we're increasing into that point. And then on the other side of it, it's negative, so we know we're decreasing. So that tells us, by the first derivative test, that this here will be a local max. And for 1, well, to the left of it, it's negative, so it'll be decreasing. And to the right of it, it's positive, so it's increasing. So that tells us we will have a local min at x is equal to 1. All right, so that's everything we can really get from the first derivative. Now for the second derivative, I went ahead and did the same thing. Ensured I had all of my x-intercepts included, and those x-intercepts for the second derivative end up being -0.76 and 0.76. And we'll just do the same thing we did before to find concavity of it being up and down. So it is concave up when f double prime of x is strictly larger than 0. So starting all the way at -infinity, it'll be concave up until we hit our first intercept, so -0.76. And then when we hit 0.76 to infinity. And it'll be concave down on the rest of our interval. So concave down is when f double prime of x is strictly less than 0. And this is going to be from -0.76 to 0.76. Now to find points of inflection, we need to see that there is a change in concavity. So to the right of our first x-intercept, it is going to be concave up and to the left of it is going to be concave down. So we do have a change of inflection there. So that will be a point of inflection. And for our other x-intercept at 0.76, it is concave down to the left, concave up to the right. So we also have another change of inflection there. So we found our points of inflection. We found intervals where the function is increasing, decreasing concavity, and we found our extreme value.